welcome back to my channel. I am going through as many LeetCode problems as I can in a year, and we are on question number 80 for largest rectangle in histogram. Now, this solution today is going to be in Python. Sorry, I'm putting my AirPods back in because I just got back from a walk. We're doing today's solution in Python. In full disclosure, I've not read through this. So, let's just jump in, you know? Why not? Okay. So, given an array of integer heights representing the histogram's bar height where the width of each bar is 1, return the area of the largest rectangle in the histogram. That doesn't seem hard. It is. It's going to be hard. I'm sorry. They always do this. Okay, so these examples. 2, 1, 5, 6, 2, 8. So 2, 1, 5, obviously, 6, 2, 2, 3. Sorry. Jeez Louise. I can't read. So this would be the largest. So 2 and 4, 4. The output is 4. Okay. Hold on. Let's read through this one more time. Let's read through this. Okay. So given an array of integers heights representing the histogram's bar height where the width of each bar is 1. So it will never be more than a width of 1. That's nice. Return the area of the largest rectangle in the histogram. Okay. I said that doesn't sound that hard, and now that I'm thinking about it, I actually have no idea where to begin. So I know for a fact I need to consider the max area. Always. So the output of this is 4. So 1, 2, 3, 4? How is this not? Wait a second. 1, 2. So output is 10. Yeah. Okay. So we can try to get that wrong. That's 4. That's 4. Yeah. Okay. That in theory would be 4. Okay, so these are the constraints. So the largest rectangle. That's just going to be the maximum area in that thing. So I don't know how I want this to go, but I know I want to start off by initializing that variable. Yeah. Because that just seems, and we're just going to set it to 0 because it's starting from 0. But, So then we need to be able to track the number of elements in the histogram. So I guess for that we need to look at the length of each, because we know the width is fixed to 1. So the length, which I guess would be height. But we also need to keep track of the elements. So let's do a stack here and create this as an open, you know what? I'm not even going to try to continue that. And then we're going to do heights. Okay. So we're going to use this to store the variable. I'm sorry, to initialize. This is initializing the variable. We're using this to store. And then this is going to calculate the number of elements. I'm trying to think of ways we can do this. So we have this number of elements here. We should be able to, and this might be the path of least resistance, to pop elements out. So let's take initializing a starting index with the number of elements in the histogram, and then say start I. So we can at least start it that way. Given an array of integers, heights, representing the histogram's bar height, where the width of each bar is 1, period, end of story. So what we could do is, maybe not. We could do a stack, pop it out, then calculate that area, and then update the starting index. Yeah, okay, let's do that. Okay, so let me try to explain this, what I'm thinking. So we're gonna do a while stack and stack -1 and 1 are greater than the heights. Then we're going to go through, maybe not. Yeah, we're going to go through and find the shorter bars. Once we do, we're going to go ahead and pop those elements from the stack and calculate the area of the popped elements. So let's say index height equals stack pop. So that is popping the elements. We're then going to take the max area and say maximum of the max area with the index, index minus I minus index. Yeah. By height. So that'll calculate that area. And then start will equals index will update the starting index. So then let's push the current index and height to stack append start heights I. Yeah, so then that maximum area is updated if the larger area is found. Easy. Not easy. Then I guess process the remaining elements in the stack. Maybe it shows a red area. I think I'm reducing this to something too easy. And I'm not reading it right. That's how it feels. So given an array of integer heights, representing the histogram's bar height, where the width of each bar is 1, return the area of the largest rectangle in the histogram. So we have the max area initialized, we have the place to store it, we have the number of elements in the histogram, then we have a starting index. So I mean, from here we just really need to process any of the remaining elements in that stack. So And it would just basically be the same and just popping them out. You know what, though? Maybe that I'm thinking of this in a too elementary of a way, because that really probably won't be good for runtime. Unless, shoot. So let's think about this. We iterate through these elements in the heights array, right? And maintaining a stack to find the rectangle, area, or square, or whatever it is, whatever you want to call it. And we have to have it be the largest thing. Everything is a fixed width, which we have there as the fixed width while stack and stack. I'm hoping it's just my brain psyching myself out. I'm just gonna write that how to process the remaining elements, just because it seems silly to feel the same. And literally all I'm gonna do is just copy this, but I'm gonna change this to n, because that's the number. That's our number of elements in the histogram. Yeah, well, stack, let's do... That's... Makes sense. Right? Because that literally just ensures that we process the remaining elements here. And then we just return the maximum area. Let's read through this question one more time. So, given an array of integers heights, representing the histogram's bar height where the width of each bar is 1, return the area of the largest rectangle in the histogram. I feel like this covers cases like this and cases like this, while maintaining this in the constraints. And I mean, the max area, if I'm thinking about this correctly, will return that. Because we figure all these things out, we pop them out, and then we do the remaining ones, and then boom. So, also, I haven't submitted anything for this yet, just so you guys can see. There's no way a hard question like this should only take me 12 minutes. I'm definitely missing something. I have to be missing something. But I'm looking at both of these things, and I have no idea what I could be missing. I guess I can just run it, and if it's wrong, it's wrong, and that's it. Does that work for people? Okay. We got 2 test cases. Here's the thing, though. Maybe I didn't take into account edge cases? Yeah. Actually, you know what? Let's do another one. Let's do some random numbers. 4, 8, 3, 6, 1, 9. Okay, now let's run it with that third test case. I just want to see... Dang. Okay. Actually, will I get a... If I say 1, 1, 1, 1, 1, and then let's do that again with 1, 2, 2, 1, 2. Boom. Okay. Let's just throw in some extra test cases in there. Just because I want to know. I just want to know. I'm thinking about that in the Jasper the Doll voice. Okay, so I think this is fine. I'm skeptical though. Oh, jeez. I mean, it got accepted, but like barely. Ooh, 14%. Yikes. Okay. Well, you know what though? I'm not complaining. I mean, that was like 14 minutes, but I think I definitely should have listened to my gut when I was second guessing this part. I definitely could have improved both of these things. That was just my initial off the cuff just thought. So definitely want to redo this at a later date. But I guess I'm not mad about the timing, but I don't think this would work well if I were like in a job interview or, you know, trying to actually like show someone I have meritable skill. Because this felt like more of an elementary approach to a problem that could be a lot more sophisticated and have a much more effective memory and runtime. So that being said, I'm going to leave this code in my GitHub repo, which is going to be linked in the video description down below. You guys, please fork it and clone it. Make it better, make it worse, have some fun, learn something new. Leave some comments for me. I would love any feedback that I can get because I am constantly trying to improve what I know and what I draw on, and stuff like this. Give me your feedback on. Maybe make an issue. Like if you think there's an issue in any of the stuff I write, go ahead and throw that in that repo when you fork and clone it. So anyway, thank you guys so much for watching. I will see you in the next video. Goodbye.